Hello and welcome, friends. So today we are going to talk about the topic that we just covered in the previous session as fundamentals. So we are going to talk about today is on just a minute. To talk about today on a topic of logarithm. So logarithm problems first session. So if you are regular to the channel, you may know by now that we cover every topic in three videos primarily. First one talks about the fundamentals, which we did in the previous session in depth. And then these two sessions are problem session one, where we do foundational level problems or problems that will make you understand what we have covered in the fundamentals and cement your concepts very well through this. And then the second session of problems, or the third session of that particular topic, will be on complex problems or little advanced level problems, where we typically focus on level 2, level 3 kind of a problem. But yeah, we have seen the problems that we are going to do in first session as well as in the second session. Both has a equal way probability to come in exams like CAT, SNAP, IIFT, XAT, or in case of NMAT. But having said that, since within a stipulated time, we may cover 7 to 8 problems today, but it's expected that you do at least 3x problems to get a understanding of this, or get yourself used to it, get your mind tuned to what we are going to cover in this topic. So in the first session, if I do 8 problems, the expectation is you would do at least 25 problems at home. Then again, in the next session, if I do another 8 problem, you do another 25 problems at home. So basically, while we cover 16 problems here, you should cover at least around 50 problems at your home. So that way, together, we'll be ensuring that your understanding of this particular concept has been completely thorough. Okay, so if you have not gone through the foundational session, I recommend you go through that first, because that will help you understand what we are going to cover today. I'll just change the size, just give me a minute. Yeah. So that will basically help you understand the formulas that we are going to cover. So like we mentioned in the previous session, I'll put the link in the description box of the previous session. So there are two type of problem primarily come in logarithm. One is the solution for x in a logarithmic equation, and there will be a logarithmic expression will be given to you. You have to simplify that. These are the mainly two kind of problem, and all the formulas that we have gone through will be very, very important for you, and we will revisit some of the formulas and when we go through the problems here. But yeah, if you have not gone through the previous session, please go through that first before we start here, or at least go take a note of the formulas that has been covered in the previous session. But yeah, also before starting, like I always mention, if you see a problem, just don't jump into the problem and see my solutions continuously at the video. You can pause it, try it for 2 minutes at your end. If see what you are getting. If you are getting, you can come back and see whether you have done it right. If even if you are not getting, you can come back and see whether you have done the problem right way or not, or where you are actually stuck and what is the solution for it. Okay. Now let's the first problem, very basic problem to start with. So if I have log of 5 1 by 15625, now I know this is basically what log of 5, and 15625 is nothing but 5 to the power 6, right? So I can write this as log of 5 to the power minus 6, right? So if something is 1 by 5 to the power 6, it can become 5 to the power minus 6. Now I know the log formula, log of a base a. If your power is x, it will become x of log of a base a, or it will become x, because log of a base a is basically 1. So this will become minus 6 log of 5 base 5, or minus 6 is your answer, right? So I hope this is clear. And again, these are particularly formulas that we have covered in depth in the previous session. and take a note of those formulas, and you can easily understand from there. Okay, let's move on to the next problem. Right. So if you see 2 log 169 minus 3 log, so this is another way of simplifying the problem. They are asking you to simplify what it is given. So 2 log 169, I can write it as 13 square. I'm just trying to simplify. Uh, Minus 3 log 221. Now, what is 221? 221, if I further divide, this is this a periodic number? We do with 7, it doesn't go. 11, it doesn't work. Let's say with 13. 13, 1 with 13. 9 1, so 17. So 13 into 17. So 3 log of 221 I can write as 13 into 17, right? Plus log 1700 plus log of 17 into 100, sorry, minus log of 1300 minus log of 13 into 100, and finally you have plus log 289 plus log of 17 square. So there are these 5 terms. So 2 log of 13 squared, the 2 will come in front. So this is 4 log 13, because 2 will come in front and get multiplied with the 2 that's already there. Minus, this is for this, we know if log of AB is same as log A plus log B. So we know log of AB is same as writing as log A plus log B, again referring to the basic formula. So this will become minus 3 log 13 minus 3 log 17. Similarly, log 17 into 100 become log of 17 plus log of 100. Log of 17 plus log of 100. Log of 1300 will be minus log of 13 minus log of 100. And log of 17 square will become plus 2 log 17. So we got all the things. So log 100 plus log 100 minus will get cancelled out. Now, if you see, we have only log 13s and log 17s, right? So let's see what is there. So I can see here there is a 4 log 13. There is a 3 log 13, and then there is a minus log 13. So this 3 will get cancelled out. Then I have 3 log 17. I have 3 log 17. I have plus 2 log 17 plus log 17. So 2 log 17 plus log 17 is 3 log 17. So things will get cancelled. So your answer is 0, right? So everything gets cancelled out with each other, right? Okay. So if you see what we have done, we have basically broken this problem into simpler logarithms, the bigger ones, by factoring them. And from there, we have applied some of the basic log uh, attributes or properties, and then we got the answer. Okay, moving to the next problem. Here it's given. So if you remember, there was a formula that we have covered. If a to the power log of a, or a to the power log of, let's say not a, let's say a to the power log of c base b. If this is something like this, then we can very well write it as c to the power log of b base a, right? So basically 9 log of 8 base 12, the first one can be easily written as 8 log of 9 base 12. Why I'm writing that? Because the next term is like that, 8 log of 9 base 12, right? So we can change this to this is becoming 0. Okay. So just wanted to illustrate if you recall this formula or not. It's a very important formula. This is so if you remember, if you see the logarithm, if you remember some of these formulas and the properties of logarithm, most of the logarithm problem will be easy for you. And that's what we're going to see in the next few problems in this session and the next session. So again, this is a simplification problem. So if I expand it, so they say first one, log of xz to the power 1/3, and then you have xy to the power half, right? Similarly, multiplication, log of xy to the power 1/4, and you have yz to the power half. And the last one, log of yz to the power 1/5, xz to the power half, xz to the power half. So this is given. So from the first one, from this one, what will come out? Half divided by 1/3, half divided by 1/3, and then log of xy with base xz. Then similarly, we'll have half divided by 1/4, log of yz with base xy. Then from the last one, we have half divided by 1/5 and log of xz with the base of yz. This is given. This a little. So then what is there? Half divided by 1/3. So basically this will become half divided by 1/3. This will become 3/2. So 1/2 divided by 1/3. So 1/2 into 3, or 3/2. So you can see in between into 3. So 3/2. Okay. Now with 3/2, what I'm getting? 3/2 into 3/2 log of xy by log of xz. So I know log of a base b is same as log a by log b. This is the one I'm doing. So this is 4/2 into log of yz by log of xy into 5/2 log of xz by log of yz. So log yz get cancelled, log xz get cancelled, xy get cancelled. So you have left with 3/2 into 4/2 into 5/2. That is 30. Oh, not 30, sorry. 60, my bad. This 60 divided by 8, or we can say 15/2. 15/2 is my answer. Okay, so what we did, we simplified the problem and then again applied some of the basic formula of logarithm, and we were able to solve it. Let's move to the next one. The 2.1x. Just increase this a bit. Yeah. You see, they say 2.1x is 0.21 to the power y. So if I go one by one, they say 2.1 to the power x is 1000. Right? 0.1 to the power x is 1000. Now, if I take log on both the sides, then only I'll be able to bring x down. So log of 2.1 to the power x is log of 1000, or I can say x log of 2.1 is equal to log of 10 cube, or I can say x log of 2.1 is equal to 3 log 10. Now we know log 10 is equal to 1, so this is equal to 3. So can I say x is equal to 3 by log of 2.1? 3 by log of 2.1. Similarly, what is there for y? I know 0.21 to the power y is 1000. So similarly, I can take in a log on both the sides and write 0.21. Y log 0.21 is equal to 3 log 10. The same way we did here. This to see this problem. Same way we did here, we take log on both the sides and 10 cube, 3 comes in front. So then I can say y is also 3 by log of 0.21, right? Okay. Now what they have asked, they have asked for the value of 1 by x minus 1 by y. Now 1 by x means 1 by 3 log 1 by 3 by log 2.1 minus 1 by log of 0.21. So from here we can write log of 2.1 by 3 minus log of 0.21 by 3. So both has 3 in common. So by 0, narrow down further. So this will become 1 by 3 log of 2.1 minus log of 0.21. So if you see carefully, 1 by 3 log a minus log b is same as log a by log b. Log of a by b 1 divided by 0.1. So log AB is log A plus log B. Log A by B is log A minus log B. Okay. So 0.21 divided by 21 divided by 2.1. So 2.1 is 21 by 10 and 0.21 is 21 by 100. Right? So 2.1 is 21 by 10 and 21 by 100. So you have 1 by 3 log 10, or log 10 is 1, so your answer is 1 by 3. Okay. So that's how we can do it. So if you see, we have found out x first from logarithm by taking log on both sides. Similarly, we found y by taking log on both sides, and then we solved what is given. Next problem. A is log 8 by log 16. B is log 16 by log 24, like log of a base b, same as writing as log a by log b. And C is log 24 by log 32, right? Now, what is BC into 2 minus A? This is 2BC minus ABC. So let's find out what is ABC and what is BC. So if I say BC is log 16 by log 24 into log 24 by log 32. 24 get cancelled. So BC is log 16 base 32. So log 16 by log 32 is same as log 16 base 32. So log of A by B is same as log of A base B. So what I'm trying to say is log of A log of B is same as log of A base B. So this is log 16 base 32. Let's see what is ABC. So A is what? A is log of 8 base 16, right? And BC is log of 16 base 32. So into log of 16 base 32. So from here we can say log of 8, log of 16 to log of 16, log of 32. So 16 get cancelled. So ABC is log of 8 base 32. So I know BC, I know ABC. So BC is log of 16 base 32, ABC is log of 8 base 32. Okay. So let's see what has been asked. So they have asked for 2BC minus ABC. So 2BC means 2 into log of 16 base 32 minus log of 8 base 32. Right? ABC is log of 8 base 32. So 2. So that means this is log of 16 square base 32. 16 square base 32 minus log of 8 base 32. So from here we can see log of 256 base 32 minus log of 8 base 32, right? So if we can narrow down further, then we'll see. So log of 32, and in between we will have 256 by 8, or we can say log of 32 base 32 or 1. So basically what we have used here, so from this step to this step, how we got it? So we know log of a base b minus log of c base b. If you have this, so it is same as writing log of b c. So basically, if you think this is base is same, so log a minus log c is basically log of a by c. So log a by log of a by b is same as log a minus log b with the same base. Similarly, 256 by 8. Okay. If there is any doubt in understanding some of this problem, please drop a note. We'll be able to help you. Now the next problem, this is log of 5, 6 plus 4. So basically you have to find the, okay, so they are asking for range of x is how much. Okay. So if I say log of 5 modulo base 5 with modulus of x plus 4 greater than 1, right? So in this case, if you remember what we have done earlier, we have say log of a base b is equal to x. So that means a is equal to b to the power x. A is equal to b to the power x, again the basic logarithm formula, right? So in this case, what you have to do, right? Of x plus 4 greater than 5 to the power 1, right? So mod of x plus 4 must be greater than 9. So then I can say minus 9 must be less than x plus 4, and x plus 4 must be greater than 9, right? So minus 13 less than x and x greater than 5. Right? So these are the two range of x, minus 13 less than x and minus x greater than minus 5. Okay. Sorry. This is 5. But this is not 9. This is 5. So this will be 5. Okay. Just a minute. So this will be 5. X plus 4 greater than 5. So minus 5 less than x plus 4. And x greater than, sorry, x plus 4 greater than 5. Same basic inequality. Since it's a modulus, so I need to have more than minus or plus 5 in an absolute term. When I say in an absolute term, so that means I need minus 6, minus 7, or plus 6, plus 7, something like that. So that's why minus 5 has to be less than, or sorry, this is greater than 5. So I need, what I need here is, so I need -6, -7, -8, so something like that. So x plus 4 has to be less than -5, not -5 less than x plus 4. X plus 4 has to be less than -5, so that I get -6, -7, -8, and then put it into the modulus, and the value becomes more than -5. It's more than 5. So then x plus 4 less than -5, or I can say x less than -9. In this case, x greater than 1. So x either less than -9 or greater than 1 should give you the answer. But yeah, more importantly, here you need to understand how this is coming. So these are the remembrance of the formulas and how we can leverage them. Okay. Now this is the value they have asked you to simplify. So there are 4 in the base A. There are 4 powers, right? So let's go one by one. So log of A, first one, log of A, second one, log of A, third one, and then in the fourth one, there are 4 powers, so 1 power will come out. So A, log of A, so if I just want to keep one A here, the whole power, the 4 powers will come. So A. So all the 4 power will come out. Then it will become log of A base A. Now log of A base A is 1. So this entire term is nothing but 1. Okay. So then from here we can say log of A, log of A base 3A. 3 times there is a power in A. There are 3 A's in the power. So again, if I keep this term is 1, so A will come out, log of A, log of A, and then I have A to the power A, and in between I have log of A base A. So this will be 1, so that's taken care. Okay. Now here also I will see log of A, A to the power A. So this 2A will come out. Then we'll have log of A to the power A, log of A base A. So again, this part is 1. So I'll get log of A to the power A. Again, this A only will come out. So A and A base A. So this part is 1. So your answer is A. Okay. So though it looks complex, but you see there are 4 logs and then there are 4 A's into the power. So it will all narrow down to A. So I hope this examples were helpful, but again, this may not be completely digestible if you are not, if you have not gone to the fundamental session where we have covered the concepts or the formulas in great depth and with examples. So basically, you should go back to the foundational session and see how we have solved them, and then you can come back and see some of these solutions. And that's where it start making sense how we are using the formulas with those properties of logarithm. And this is possibly the only part of algebra where you need to remember some of the formulas. Rest are basically concept based, and you can very well do without remembering many set of formulas or properties, I will say. But logarithm is one place where you have to remember some of the properties, and more you practice, these properties become a mind muscle connection. So it will automatically come to you if you see this problem. So again, if I have done 8 problems, if you do 24, 25 problems at home, you will be able to absolutely master the formulas, so that you see a problem, and when I apply a formula, or when you are going to apply a formula, you will be able to easily identify what we can apply. So with this, so let's cement our foundational understanding with do around 20-25 problem at home by applying different formulas or where different attributes are used. and then we will jump into the complex problems of logarithm in the next session. Okay. So if this is helpful, please like, share, subscribe for the algorithm, and see you next time. Thank you.